So now we're in section 4.2, which is about the slope of a line. So let's take a look at this up here. Slope is the rate of change between any 2 points on a line. So rate of change is important. It is the measure of the steepness of a line. So as demonstrated over here in this drawing, the slope is 3/2, so it's rise over run. So you can go up 3, then over 2, or over 2 and then up 3. It doesn't matter. But just remember, slope, which is indicated by the variable m, is rise over run. So it's the change in y, so y2 minus y1 over x2 minus x1, which can also be written as delta y over delta x. So if you were given 2 points, let's say 1, 5, and 3, 7. Okay, so let's name these. So this is, we'll erase that. This is x1, y1, and this is x2, y2. Okay, so if we want to find the slope between these, remember our formula is m equals y2 minus y1 over x2 minus x1 equals, well, y2 is 7, so 7 minus y1 is 5 over x2 is 3 minus x1, which is 1. 7 minus 5 is 2. 3 minus 1 is 2. 2 over 2 is 1. So m equals 1. So you could have these two lines, and you could find them using this equation, m equals y2 minus y1 over x2 minus x1, which definitely needs to be in your notes. And you could find that the slope is 1. You can also find the slope just by looking at the graph. So if we have 2 points on a graph, we have -1, -2 here, and 1, 1. We can just count the graph as well to find the slope. So if we start at -1, -2, and we go up 1, 2, 3, so my m is going to be 3 over, and then over 2, 2, 3/2. And you can leave your slope as that. You don't need to rewrite it as 1.5, because if you just leave it as 3/2, it's easy to see the rise is 3, the run is 2. Slopes can be both positive and negative as well. So here we have a positive slope, so that always rises to the right. And then here we have a negative slope. It always rises to the left. So if the m is -3 over 2, you have a line. You can go up 3, so if this is 1, 2, 3, we'll go 1, 2, 3. But then that was a positive 3, so we would have to go a -2, so 1, 2. So this is 0, 0. So our line would look something like this. Well, let's say first we go down 3, 1, 2, 3, and then over 2, 1, 2. The line is still on that same slope. So when it's a negative slope, you're going to either rise up and then your x is going to move negative, or your y is going to move negative and your x is going to move positive. If your slope, let's say your slope is, be sure that you recorded that positive and negative slope and just draw a picture so that you have an idea. But if you had a graph x, and this is y, if your slope was m equals 5, we talked about this in class a little bit, but that's the same as 5 over run, right? So 5 over 1. So this is your rise, and this is your run. So let's say our x-intercept is at -3. So we would go up 5, 1, 2, 3, 4, 5, over 1, and our graph would be something like that. can also be 0 and undefined. So, a slope that is undefined, what kind of line is that? Do we remember? It's a vertical line. So if we have a line through x equals 2, that's a vertical line, and m is undefined. Undefined, okay? We can also have a slope through y equals 2. So this line is y equals 2. And in this case, m equals 0. So for horizontal lines, m equals 0. Because the rise, there is no rise, right? We're not going up. We're only going over. So it's 0 divided by some number, which could be infinity. That's the infinity symbol. And 0 divided by any number is always 0. However, for the previous slide, we were talking about a vertical slope, in which case it was any number. So let's say, any number, let's say 9, because since it was a vertical line, the rise is a number, and then the run, it doesn't move horizontally at all. So the x movement is 0. And so any number divided by 0 is undefined in math. Undefined. So that's very important to remember. Horizontal slope is 0, vertical slope is undefined.